Worksheet 4G also about the area moment of inertia. For this, the section shown determine the moment of inertia of the beam about the x-axis. So that is the neutral axis. And in this case, the shape in the x-axis, as you can see, is not symmetrical. So the first thing is we need to find out the centroid, locate the centroid of this cross section. So from that, let's find out the centroid from the bottom of this beam. So let's put down here the bottom of the beam. So set that is 0 here. So we want to first find out where is the y bar of the whole shape first, of the whole composite shape. And from that we can, of course, you know that is the centroid there, that is the centroid. So we need to find out y bar because this is not standard shape. Just like the previous problem we do in 4F, this one is symmetrical about x-axis. So the centroid will be in the center. So, but this one we need to find out centroid. So here, similarly, we have to, this is composite shape, we have to break it down into standard shape. So let's break it down here. There. So we have 3 rectangle. So let's name each of them. So here I can call that is shape number 1. The middle here, shape number 2. And that one here, shape number 3. At first, we need to find out the centroid and make a table, something we learned in engineering mechanics. And we get that from there. So let's first make the table with shape, and we have 3 shape here, and then we have find out the area. So whatever, like I say, for the mass moment of inertia, whatever the areas you the mass move replace with a, for the centroid about geometry, so the areas. And then we have the I for each standard shape, and then y bar for each standard shape times the area of each shape. So let me put that ai for each shape, ai for each shape. So easy to find out there. Okay, so from that we will have continue to have another column coming, but let me just focus on this 4 column first to find out the centroid first, and then we continue to complete the other column later on. So for the shape, we have 3 shapes as shown here. The first one, and don't change the orientation. That shape with the first shape number 1, and you can see, and it's positive because that is solid. So that's shape number 1, and that actually positive. And shape 1. Right? And from that shape 1, you have the 6 inches and 2 inches. 2 inches. And then we have shape number 2. Shape number 2. And it's also positive because that is a solid, not the whole. And just like that in number 2 in there, number 2. So in terms of the size, you have the width is 2 inches, and the height, as you can see, the total is 9. The top one is 2, 5. So that middle one here is 4 inch. Make sense? So that is 4. So you have that will be 4 here, 4 inch. And then the last one is the shape number 3. Shape number 3, also positive, and that shape 3 just for us to know. And in terms of the dimension, the horizontal is 4 inch and the height is 3 inches. So make easy, don't put the unit. Okay, put inches. So the areas, very simple, plug in. Area 6 times 2 equal to 12, and it will be unit inch square. And then the vertical one here is, I say 4, not 2. You see 4 inch there, so it should be 4 in here, 4 inches. So 4 times 2, it equal to 8 inches. And then 3 times 4 is 12 inches. 2 inches square. And then Y bar for each shape. So what is Y bar here? Y bar I here is that is the centroid of the shape. And because we measure it from the bottom, here, the bottom. So use basically the Y1. Okay, and similarly, we can also find out the centroid of. So this is number 1. G. Let's see that either G1. We have this is G2, and this is G3. So we need to find out the Y for each. So G1, Y1 in there, as you can see, it equal to 9 minus 1, so it will be 8. Because that 2 here divided by 2 inches divided by 2 equal to 1 minus 9 inches for the whole length of the vertical length of the cross section, so that you can have that is 8 inches. And then you have the number 2, which is Y bar 2, 1, that is Y bar 2, and that will be 2 plus 3 is 5. 2 plus 3 is 5, because that is rectangle, so it will be 5 inches. And then of course we have that is Y3 bar, and that it will be 1.5 inches. And from that you multiply your 2 columns to get the answer. So it 12 times 8, so it's 96, and that unit it will be inch cube. And 8 times 5, 40. 12 by 1.5, it will be 18. And sum of this, so actually that is sum of areas. 12 plus 8 plus 12, 24 plus 8, 32 inches square. And sum of AI, it equal to 98 plus 40, so it will be 138 plus 18, so it will be 154 inch cube. So those two, if you recall the centroid, to find out the centroid equation, we have it for x. We have that, right? X, AI divided by I. So from that we can have that equation here. Equation Y bar. What we want to find out is sum of all the YI, AI, if I sum up all the areas, so it will be 154 divided by 32, and that what we get is 4.813 inch. What does that mean? We find out now. That one, Y bar. it now equal to 4.813 inch. Yeah, 4.183 inch from that. So when we know the y bar, we can go ahead to apply the parallel axis theorem to find out. If you recall the parallel axis theorem that have here, parallel axis theorem, recall parallel axis theorem, and that is for the I for the whole composite shape equal to sum of all for each shape, area moment of inertia for each shape, plus A for the shape, plus dy square. So from that we can have, we make another three columns. The first column is we want to find out what is the I for x, and in this case it will be int cube, int 4, power 4. And then we will have the next, it will be what is d, what is dy, and dy in this case, as you can see by definition, what is dy by definition, it distance from the neutral axis of each standard shape to the centroid of the entire shape. In other words, it will be the centroid in that direction of standard shape to the centroid of the entire shape. So go back to here, we basically, it will be equal to, and just make it the absolute number because you will square anyway in the parallel axis theorem. Here, right? Parallel axis theorem. There, so you can have it equal to absolute of y for each location of each standard centroid of each standard shape to the centroid of the composite shape. And then we finally apply the centroid axis theorem, that will be what is the I x plus a I if you want, or d square or a. So unit here is inch, and this is inch power 4, inch 4. So Ix again, it will be parallel power 1 cube perpendicular 3 power 3 divided by 12 for rectangle. So you can see here it will be equal to 6 times 2, because about x, 2 is the perpendicular cube divided by 12, and that you will get this number equal to 4. Similarly, the shape here, you have 2 times 4 cube divided by 12, so you will get that is 10.67 inch 4. And then this one, it will be 4 times 3 cube divided by 12, so you will get 9 inch 4. And then dy from y I minus y bar, so y for position 1, as you can see, it equal to 8, as we already find out, so that is put here at 8 inch. This is 1.5 inches, and y bar 2 here is 5 inches as we saw before, and from that we can plug in here, and y by 4.813 minus 8, so that it will be this one, 8 minus 4.813, so that you get 3.187. That one equal to 5 minus 4.813. So the from the centroid of standard shape to centroid of the composite shape, and that it will be 0.187. And this one, of course, you can use absolute here from y bar 3, so 1.5 minus 4.813, and why we just use absolute, because we square on the last column, as you can see there. So we don't care which positive or negative. 313. So from that we can apply the ix apostrophe plus a I 12, for example, for the first shape, time the d 3.183 square. So with that you can get this number is 125.9, this number is 10.95, and this number is 140.63. And we sum all of this, actually that is the parallel axis theorem, sum all of that number. So the sum of all of that column, ix plus ai dy for each shape, and that equal to 278 in 4. So from that you can see the bottom line, the area moment of inertia about the x go through the centroid of the composite shape, it will equal to 278 in power 4, and that the units in 4, and that should be the answer for this problem. Now for practice, you should be able to use this same concept in worksheet 4G to do the next the two problems C and D, which is even simpler, only two shapes, for problem 4F.